Hi guys, in this video we are going to see about the power factor correction. See what are the various methods of the power factor correction. Before going into in depth into the topic, let us get refresh about the what is actually not only in this video, in the series of video we are going to see the power factor corrections and various power factor correction ICs also. Okay, so particularly active power factor correction. So before get into this one, this particular video we are going to see the basics about the power factor, what is meant by power factor, and what are the various causes for the low power factor, what is the impact of the low power factor, and how can we improve the power factor, what are the various methods to improve the power factor, and different types of the power factor improvement methods. And we are going to see some terminologies also. What is meant by harmonics? What is the total harmonic distortion? And various names like what is a power triangle? What is the unity power factor? Low lagging, leading power factor? And what is the displacement as well as distortion power factor? Those kind of things. So because why? Let us get into the clear about the basics. Then we go into the in depth about the power factor correction. That's the intention. And as usual, I am requesting you please click the like button as well as please subscribe for this channel, which will encourage me to do more videos. Thank you guys. Let's go into the topic. See, let's start with the definition for the power factor. The power factor is defined as the ratio between the real power, real power between the apparent power. Okay, that means watts divided by the VA. Okay, and you may remember that in high school you may also come to know that power factor is the cos phi. That is a cosine angle between the voltage and current. And we are going to see where it is applicable, where it is not applicable. Okay, and so by the most generic power factor definition is nothing but the ratio between the real power to the apparent power. And in various textbooks you may see little bit different names. The real names in some textbooks it is mentioned as a useful power. In some cases it's mentioned as active power or workable power, workable power, like that. So but ultimately the unit will be watts kilowatts. Okay, and the apparent power also in some cases it may come as a total power or apparent. In little bit different names it will be there, but the unit will be VA. Okay, the one more thing is magnetic power or reactive power. That is a reactive power is nothing but the it's not doing the useful power. So as we are saying that in that if you see the below the power triangle, the below one is a useful power. The magnetic power is the not useful power actually. It's a power flow front and go on back to the from load to supply. Okay, so the power factor is the decimal value between the 0 to 1. And why it is very important we are saying is, see a system having 0.65 of the power factor number, it draws 1.5 times of the input current than the system having 0.99 power factor. So that much power is wasted, as well as the components associated with the power transmission components that has to be capable of having more power, right? So those are the drawbacks. Okay, let us see. This is the definition for the power factor. It is the ratio between the real power to the apparent power. Okay, so next get into the power triangle. See, if you see the power triangle, you can see here as a useful power. That is the active power or real power here. And this is the total power supplied to the system. This is the power supplied to the system, and this is the useful work. And this magnetic power or reactive power is the power flow between the inside the circuit. Say for in SMPS circuits, in the inductor it has to store and it has to go to the capacitor and then it will go to the load, right? So those power flows in between the load to supply. That is called the magnetic power, which stores inside the magnetic elements and does not do any useful power. That not used for the end application. Okay, so if you see, the power factor is nothing but the ratio of kilowatts to kVA. Okay, arrows here also you can see. So the actual real power, the useful power is nothing but the supply power, apparent power multiplication of some numerical number. Okay, so when it will be the highest, it will come means when it becomes 1, right? So then only all the power supplied to the system, it will be effectively utilized. That means so the ideal case is unity power factor. Power factor will be 1. That's the ideal case. How much we are closing to near to that one, that much our system will be more efficient. Correct? Yeah. Let's get into the explain further here. So to make more and more near to the unity power factor, this component, this magnetic power has to be as less as possible. Correct? Then only the angle between the kilowatt to kVA will be less. Correct? So you know, right, cos 0 is the 1. So when the theta is 0, nearing to 0, the value will be very less. Cos 0 is 1. So the power factor will be 1, I am saying. Correct? Okay. So okay, come to here, this picture. See, if as you are seeing the top side, here the useful power is 100 kilowatts. To do this 100 kilowatts of work, the system is supplying 142 kVA, right? And 100 kVA is getting wasted. Then we are getting the power factor of 70%. Okay, if we are reducing the reactive power, the magnetic power, from 100 to 33, then our efficiency becomes 95. That means our power factor will be 0.95. Correct? In this case, to do the 100 kilowatts of work, only 105 apparent power, that means total power 105 is sufficient. Correct? So what are the methods we have to reduce the reactive power? What are the causes for that reactive power? What are the causes, what are the various ways to reduce the reactive power? That we have to see it. Then we can improve the power factor from 0.6 or 0.7, or from there to see from here 0.7 to 0.95 it is increased, right? So in that case, how we are going to increase it, that we have to see it. And one more terminology we are you may come to know various things is that lagging power factor, leading power factor, unity power factor, and power factor, low power factor due to displacement, low power factor due to distortion. Those are things we are going to see it now. See, power factor, that issue, the low power factor, how it has happened, that one method I am saying is displacement power factor. Power factor due to displacement. What is that? See, the very first figure here, if you see it here, voltage and current are in phase. Okay, this is a pure resistive load, in the sense the current, this is supply voltage, we are supplying the voltage, and the current draws by the load, it is following exactly, it's in phase with the supply voltage. Okay, so now it is called as a unity power factor, because here phi is 0, cos phi is 0 means its power factor is 1, that is unity power factor. Both ratio between the kilowatts and the kVA is 1. Okay, ratio between the active power to the apparent power. That means all the power supplied to the load is effectively utilized by the resistive load there. Okay, but in real case, in practically all, it will not be a only resistive load. Say for example, motor, that is definitely inductive load. Okay, so in that case, inductive load, the supply voltage we are supplying from the supply, and the current draws by the motor, it is it will be lagging, it's just not in phase with the voltage. It's here as showing it's lagging with the phi. So here the power factor is nothing but the cos phi. Here this first thing can be applicable. Power factor is nothing but the cos phi, cosine angle between the voltage and the current. So that is the power factor here. So in the same way, if it is a load is capacitive load, then the current is leading the voltage. So which one, voltage or current? The load current is lagging or leading. If it is the load is the inductive load, then lagging power factor will happen. If the load is capacitive load, then leading power factor will happen. Okay, this is called the displacement power factor. Okay, the power factor issue due to the displacement. And one more thing will be there, power factor due to the distortion. Let us see and come back. Let us see what's the displacement power factor we are seeing here and distortion power factor. See, let us see the distortion power factor. Here, if you see the load is non-linear. Non-linear means it's not continuous load. Just see in ambulance, a light is flickering and coming back, right? It's on, off, on, off. So it's not continuous load. It is an intermediate load, non-linear load. So in those cases, the supply will be the same amount of supply here I am showing here, right? But the current consumed, it is in phase with the voltage only. As you see here, it's in phase with the voltage only, but not exactly as it is here. Okay, this is one cause. This is called distortion power factor issue. It's the waveform is distorting here. And one more factor for distorting power factor is due to harmonics. Okay, due to harmonics also the distortion power factor will happen. Here in this case we can't say the power factor is the ratio between the voltage and current. Correct? So here in displacement power factor we can say the voltage between the cosine angle between the voltage and current is called the power factor. So that's why I generally say that generic power factor differential will be the ratio between the active power to the apparent power. Okay, yeah, come back to the here displacement power factor. If it is a displacement power factor issue, how we can address this? By adding a capacitor, by adding a synchronous generator, or by adding a synchronous motors, we can mitigate this issue. We can solve this issue. As we are showing here, you can see here, see the three-phase load is there. The load is the motor, inductive load. Okay, so if you are adding a synchronous motor here, and see this is the IL, it's lag, and whereas this one IM, it's leading. So the current will be in phase, its cosine angle between the voltage and current is becoming less. So power factor is getting improved. So this is the displacement power factor issue and how we are going to solve it. And when we are coming into distortion power factor, we are saying the displacement power factor issues due to the inductive loads. How about the distortion power factors? What is the culprit for creating distortion in this one? See, that is the harmonics will generate it, or non-linear loads will generate it. Okay. See, for example, what are the various non-linear loads? And what is a harmonic we'll see, as well as what are various non-linear generic non-linear loads. Any converters, any rectifier circuits, any pulsating load. That means as you say that the strobe light, the it's blinking kind of things, on off. So those are the things it will generate the non-linear loads. And the harmonics will generate. What is meant by harmonics? That also we have to see it here. Okay, so here in this waveform we are seeing the fifth harmonic. This waveform is called the fundamental. This is what our required supply voltage, it has to be there. But in addition to this one, we are going to get this also. See, the 1, 2, 3 and this 4 and 5. So it's called fifth harmonic. So inside the fundamental waveform, similar to that, the fifth harmonic waveform is appearing. This creates a distorted waveform like this. Okay, so due to this also the low power factor issue will happen. For this one, we have to do the power factor correction. That's what we are going to come into our focused topic. What are the various of power factor corrections? Either we can do it with the active power factor correction, that is one thing, using the boost regulator and using that particular ICs, power factor correction ICs, we can do it. That's called active power factor correction. And one more thing is passive power factor correction. Passive power factor correction, we are going to use only passive components only, like capacitors and inductors and those kind of stuff. That's all. So cost point of view, the passive power factor correction will be less, but that's not more what do you say, more efficient way of results. Okay, so I will show you here. This is the input power factor, input current without any, this is the input voltage, this fourth one. And as we seen previously, the distortion power factor point of view, this is the input current without any power factor correction, this is the input current. But with uh, passive power factor correction circuit, by implementing the passive power factor correction circuit, by that means adding a passive components, we are getting the waveforms little bit improved here, right? Okay, whereas with active power factor correction component, we are getting much better waveform, which is similar to the voltage. That means our power factor will be improving. So implementing the active power factor correction circuits, that's what we are going to see. And yeah, this we are going to see it's what is the various causes of low power factor corrections and how we are going to improve the power factor corrections. That low, as we discussed before, inductive loads are the main cause for the low power factor correction for the displacement power factor issues. So inductive transformers, inductive motors, HID lightings, high generators, those are things. And how we can improve the power factor. Why we have to improve the power factor? This is the thing. This is the main thing. Why we have to reduce improve the power factor. We can reduce the I square loss. Okay, we can reduce the electricity bills, and it is the international standards, IEC standards. Various standards are recommending we have to use the power factor has to be so and so level only has to be allowed. So because of that also, that power factor has to be improved. So let's summarize into the picture. What are the, we have seen what the various basics terminology, like what is meant by power factor, what's meant by harmonics, what's meant by the distortion, displacement power factors. And now let us focus into the active power factor correction method in the upcoming videos. Thanks for watching this video, guys. Take care. Bye.